Marathon, a full week of free online courses in some of the leading web development technologies and concepts. JavaScript Marathon is proudly presented by This.Labs. We partner with enterprises interested in transforming their digital assets, upskilling their teams, and finding novel avenues for advanced integration. If you're interested in seeing some of the work we've done with our amazing clients, take a look at our portfolio page at this.co/portfolio. This.Labs is hiring. If you're a senior software engineer or engineering manager, we'd love to hear from you. Send us your info at jobs@this.co. And we have a ton of upcoming events. Tracy Lee and Jesse Tomchuk will be hosting folks from Contentful, Strappy, Sanity Builder IO, Keystone Directus, and at State of Headless next week. Evan Yu and Simone Cuomo host State of Vue with important updates in Vue. And then State of Web Components happens August 9th. Tracy and Jesse are back with our very own Nacho Falk, folks from Solid.js, Lit, Stencil, Marco, Svelte, and a familiar face from Qwik. And speaking of that familiar face, super excited to introduce Mishko Hevery. He will be presenting Qwik, a no hydration, instant on, personalized web application. Welcome to JavaScript Marathon, Mishko.
Thanks for having me, Sarah. It's a pleasure to be here.
Absolutely. I will hand the keys over to you.
Thank you. So let's talk about Qwik and what Qwik is. And so Qwik is a new kind of JavaScript framework. And I know what you're thinking, like, hey, don't we already have lots and lots of JavaScript frameworks? Why another one? And so I think it's important to kind of start with the background of like why we built another kind of framework. And I think the best place to start is to talk about hydration. And hydration is basically this idea that when you server-side pre-render your content, so your browser delivers a piece of HTML that could be represented by this box right here. Before you can interact with the content, you actually have to download your application itself, and then the application has to execute. And when the application executes, it has to do reconciliation. Reconciliation is basically where the application figures out where the listeners are in your page and attaches the listeners to your DOM. And so when you navigate to a classical web page, right, you will see content delivered to you through server-side rendering. That's pretty quick. And then a huge amount of JavaScript has to execute before the page is actually interactive. And this time from this location to this location is really what's known as hydration. And it turns out hydration can be very expensive. On a mobile device, it can be multiple seconds before the page is interactive. And resumability is basically a different kind of an idea. And resumability aims to basically just deliver HTML and have the application interactive immediately after delivering the HTML, basically skipping all of this work right here. And maybe the best way to kind of show this is with a demo. So this is our homepage, written both in hydration on the left and resumability on the right. And what you're seeing here is before the page goes gray is JavaScript running. So let me show this again. The two contents basically show up right about the same time, but as soon as the content shows up on the right, it is ready to take on click listeners or interactions and so on and so forth, whereas it takes several seconds of execution on the left before the page can be up and running. And so the goal of Qwik is really to have applications that have faster startups. And we think the faster startups actually makes a lot of sense because, well, if we go to what Google has to say, is they basically have lots of studies that say, like, for every 1 milliseconds, you get 1% improve of conversions, 20% faster is 10% more conversions. And basically, there's lots of studies that show that if you can deliver the content faster to the user, you'll have better conversions, better profit. Your website is going to be more highly rated. People will like to visit it more often, and so on and so forth. So this is an important goal to go after, but existing frameworks kind of have a hard time getting there. And the reason for that is hydration. Okay, so let's back up a second. And now let's talk about, like, well, how is Qwik different? So one of the things about Qwik that we wanted to make sure you have is that we still have the same component mental model. In other words, when you're developing Qwik applications, you should be thinking about the whole thing in pretty much the same way as you've been building web applications up to now. So the mental model for building it is the same. What changes, though, is what actually happens on the other side. So existing frameworks, they usually care about rendering on the client, and that's kind of all that they care about. And because of that, there's a limited of kinds of things that they can do. Now, if you compare that to Qwik, Qwik, of course, cares about rendering on the client, but it also cares about rendering on a server, serializing the data, creating bundles, prefetching those bundles, and delivering all that content to the client. And so because Qwik cares about the problem end to end, it can deliver things that other frameworks cannot. So let's kind of hop into a bunch of demos to kind of show off the capabilities of Qwik. So here's a bunch of demos. Let me just start with the first one. And let's look at what's happening in here. So this is a very simple page that is, maybe we can look at it from a code perspective, right? So we just have our component. And inside of our component, we basically show our logo and some content. Nothing over here is particularly unique, especially if you come at it from a React point of view. You should be looking at this and saying like, hey, this is exactly what I'm used to. So it's a very familiar deliverable experience. And if you look at what's rendered on the outside, you'll get what you would expect. But also we're running this in a dev mode. And so we have something called hot module reloading going through Vite. And so these pieces of JavaScript that are downloaded here are part of Vite, not part of the framework. And so we're going to filter them out and say, actually, we're not interested in Vite because this is for developer purposes only. It's not going to be in production. And what I'm going to show you here is that when we navigate to this page and maybe look at JavaScript downloaded, Qwik was able to determine that actually there is no JavaScript necessary for this particular page. And that's because if you look at the content of it, it is static, right? There's nothing that the user can do to change this. And so Qwik has this property that it says, hey, I'm only going to deliver JavaScript to the client if I can determine that it's actually needed. And so it's a form of what we call dynamic tree shaking. And it can be it can really remove a lot of behavior that you don't normally need. Now, of course, this is a non-interactive page, and so the fact that no JavaScript got delivered to the client is really not that exciting. Let's actually go and visit a counter. And so now we have a more interactive page, and we can click hello, and the hello should print the it prints hello. It prints ABC in the client. Perhaps we can change the text here to be something more useful. Hello world. And this is where automatic module reloading will get into place. So if I now, if I refresh the page, whoa, why is it not updating? Okay, I don't know why my module reloading is not working. Sorry about that. Here's our code. And so what I want to show is the application, when you look at the network tab, again starts with no JavaScript, right? Because to render this page, we didn't need a JavaScript. Now, when I go and I interact with the button, when I click hello, you can see the behavior happened. And you can also see that the code downloaded in order to make this thing happen. Now, what's interesting about this is when you look at the kind of code that's downloaded, you'll see that the only thing downloaded is actually what was necessary to process this particular event. So this is a component that has lots of stuff in here. There's a template. There are 2 different behaviors. And yet Qwik was able to zoom in and say, actually, the only code that we have to download is this bit right here. And so Qwik was able to extract it and deliver just this code over here and nothing else. Now, if I go click on the other button, obviously we'll increment the count, and clicking on a second button forced us to download even more code. So in this particular case, we downloaded the behavior of incrementing the count, the framework itself, and also the JSX, which is the template for re-rendering the UI portion of the page. And so this is a very different kind of behavior from existing frameworks, right? Existing frameworks take the JavaScript and they front load it. They download everything ahead of time and they execute everything ahead of time. And this downloading and execution is basically what we talked about being the hydration, right? The expensive part. Where is it? This part right here. And what we're doing here instead is we're kind of getting rid of this part in order to make the application start fast. And so now let's talk about other things. So in order to be able to hit click, we increment the code over here. But in order to increment, we need to know what the initial state is, right? So we needed to know that we started at 10. So it's not sufficient to just be able to download the function, the code that actually does the behavior. It is also necessary to be able to load the store, restore the state of the system. So let's look at the counter. So the counter definition has, we declare the state of the system, the store that you want to store the data. And then in here, we produce a data binding, and we have code that does the incrementing. And what needs to happen on the client is that if you go and navigate to the button, you will see that this button has an on-click event. So the system was able to serialize the information about the button into the HTML. So because it was able to serialize that information, it knows what piece of code to download and what symbol to execute and what state to restore. This bracket 0 talks about a state that needs to be restored in order to make the incrementing of the application work. Now, this is very different from existing frameworks, because if you look at the HTML that's generated on a server side, it lacks any information to tell you where the listeners are. And because there is no information about listeners, the framework has to download the application, execute it eagerly, and figure out where the listeners are through execution of the application. By flipping the kind of the way things work around, we were able to serialize the information about which piece of code needs to be downloaded and lazily download and execute that piece of code. But it's not just about lazily downloading and executing it. We also have to understand the fact that, actually, this store here closes over this variable. So this variable has to be restored when we go and click on this button. And this is done through this use lexical scope, right? So this thing kind of recovers it. Now, but notice that as a developer, I didn't have to do any of this stuff, right? As a developer, I just wrote my counter the way I normally write my counter, with state, binding, and behavior all inlined into a single file. And what Qwik framework did was successful at breaking it up into pieces and pulling everything apart and understanding that there's a relationship between incrementing of the count and downloading of the JSX that re-renders the piece of code. And so the whole system is very lazy in its nature. What I mean by that is it really tries hard to make sure that only the minimal amount of application code gets downloaded to the client, to the UI, instead of doing everything up eagerly. And the other kind of thing to notice is that as you interact with the system, more and more code gets downloaded. So let me show that maybe from a little more complicated demo. So here's a to-do application. And again, notice we start with no JavaScript. And as we interact with the application, more code downloads. And as I hit enter, even more code downloads. And as I go and I perform different operations on this application, deleting, let me see if I can get rid of this, checking things off, entering a edit mode, and so on and so forth. As I'm working with the application, more and more code is being downloaded. So the application has been spread. Instead of forcing all of the downloads to happen eagerly in here, which is basically this green box right here, we have changed it so that we're spreading the content over a long period of time. And because of that, we don't have that initial expensive startup at the very, very beginning. Now, an important part of this is what we call reactivity. And reactivity allows us to focus on individual pieces. So in this particular case, let's get the reactivity example. We have a reactivity component. We have a stored, which is a count and debounds. We have a watch, which allows us to track the count and says when the count changes, then we should set up a timer for 2 seconds and copy the value over to the debounds count. And then we have a child component called child, which prints the current count And then it also has a grandchild that prints the debounced value. And what I want to show you is, again, we start with no JavaScript on the client. So let's get the console going over here. And when I start clicking, you can see that both code downloaded, but also every time I click, it says, it shows you that we have downloaded, count has changed, and the child has re-rendered. But notice what happens 2 seconds later. Let's refresh this again. So I click, and 2 seconds later, the grandchild re-renders. So the system is able to look at all the components and say, instead of re-rendering everything all at once, which is a typical behavior for common frameworks, we can break things up into pieces and say, actually, the only thing that I need to re-render right now is the child component. And then 2 seconds later, I only have to re-render the grandchild component. And so again, if you look at how the code downloads, so clicking downloads some code, 2 seconds later, more code downloads. And this is the common theme for this particular thing of lazy loading, of just getting just the bare minimum of the code necessary to make this work. And again, going back to the source code, there is nothing specific that the developer had to do. The developer didn't have to write any lazy loading behavior, didn't have to think about lazy loading, didn't have to think about a relationship between components or any of that sort. It's just something that naturally comes to be. So we should probably talk about, like, how does the magic work? So the way this magic works is that every time you see a $sign inside of the URL, that is both a hint to the developer as well as a hint to the what we call the optimizer, that a lazy loading should happen here. So this $sign basically means that the function that follows, this function right here, is a lazy loaded function. And then inside of it, there is another $sign here, and shows this lazy loaded code is a lazy loaded function, and so on and so forth. Now, the interesting thing is that when we render the top level component Reactivity, we actually say Reactivity renders. But if you go back to our application, and let's get a bigger console going. Actually, let's flip it to console mode. And if I hit plus, you can see that the child renders. 2 seconds later, the grandchild renders. But at no point did the Reactivity actually render. That's because the system correctly discerned that the Reactivity actually doesn't have to change on the client. It only had to change on the server. And so in this particular way, we can really offload huge amounts of work from the client and make sure that when we navigate to an application, they have a very quick startup performance. Okay, let's look at more demos. This is actually one of my favorite demos. So here's the clock. Actually, let's make the font bigger. And let's go into the network tab. And what this demo shows is basically a clock that's below the fold. And you can see the clock over here. And you can see that the clock is updating every second and so on and so forth. So let's refresh this page again and go to the network tab. And what you see is that there is no JavaScript present on the code at this point. And as we scroll the clock into the view, the system downloads the JavaScript. And of course, there's the two clocks. The JavaScript is downloaded basically on only as needed basis. Now, if you think about existing frameworks and how they work, this is actually extremely difficult behavior to implement. How exactly would you tell an existing framework that something that's below the fold shouldn't even be downloaded, and then when it gets pulled up to the UI, that it should download and execute and kind of initialize its behavior eagerly? So let me show this to you from a different point of view. So this is our DOM, and you can see that the clocks over here, these things are not changing. These are static. And again, if I scroll it into the view, you can see that this thing is updated, and every 1 second, the second hand updates. But you see that the second clock is actually still asleep. And again, when I scroll the second clock into the view, now the second clock is also coming up and gets updated as well. And so this idea that code should only run when it's visible is actually super powerful. And again, it helps with making sure that the browser isn't overloaded with all of the initial work that has to happen on initial road. Now, so the question might be like, well, how hard was this to implement? from a developer's point of view. So again, we have our top level component called clock. And inside of the clock, all we're doing is we're creating 40 items and then basically have code to just generate the 40 items. All the work just so that we have the clock below the fold. And then we have 2 instances of clock inserted in there. And so the clock implementation simply says, I need a bunch of styles to be loaded. I need to store my hour, minute, and second, which are the angles for the clock. And I need to have a client effect. And what the client effect basically says is that, hey, to update the clock, you need to get the current time and then compute the angles of the minute, hour, and second hand. And then, of course, we run the code to the update and set an interval to do so every 1 second. And then here's just a template for rendering the code, rendering the component. And so the question then becomes like, well, at which point should this particular client effect run? And for normal frameworks, the answer is like, well, you run it on hydration, which means hydration happens eager and early at the beginning. And so you just naturally run it when the application wakes up. But Qwik is different, right? Because Qwik is resumable, meaning that it doesn't even have kind of the concept of an entry point. Instead, it kind of continues where the server left off. And so the question becomes like, at which point do you run this particular code? And the default behavior, which you can be overwritten in by passing an additional argument here, the default behavior here says that this code here should execute when the component becomes visible. And so the execution model here is that you have a component. When this component becomes visible, the use client effect executes and renders the component and updates it. And again, if you look at the network tab, what you will see is component comes into view. The first thing we download is basically the client effect, right? This is the piece of code that says you need to update the UI. And so this computes the new positions and angles. Then we, of course, download the framework. And then the framework then realizes, yes, and now I have to download the clock itself. So this is the template for the clock, which then causes the store hour and second angles to be re-rendered. But again, notice what didn't download over here. We didn't download the top level component because the system was able to correctly identify, like, actually, that component never changes on the client. So there's no need to download the code for it or anything of that sort. And so the kind of the different behavior here is that instead of thinking of our application as this monolithic code base that exists and we download eagerly, we are in this world where almost every single function, which is declared by the $, can be downloaded in lazy fashion, right? And so you can see that all of these pieces come, every time you see a $, this behavior is a separate download that comes on as needed basis instead of all eagerly at the very beginning. So one of the things that we should actually talk about, actually, let's go back to the counterexample, is how does the system know what is the initial value? And for that, we have this idea of a JSON. And so this is the state of the application that Qwik automatically serializes so that you don't have to think about it. And in here, the Qwik says that the initial state is 10. And when I click on this button, this script tag gets consumed. Part of kind of waking up the system is to consuming and restoring the state, and so the script tag is gone. And if you look at the network tab, you'll see that it is gone because of this part over here, right? The initial behavior was to download the piece of code that does the increment, and this incrementing required me to recover the store, and so the store needed to get a hold of the current state of the system, and that's done through this use lexical scope. And again, none of this stuff is something that I had to write. It is something that automatically became available. But the point I'm trying to show here is that the state of the system is serialized inside of this JSON object right here. Now, let's go to a more complicated demo. This is our Hacker News. And I want you to notice what happened to the state of the system. Notice it's essentially empty. The system serialized the state and it said, yep, there's nothing in here. So this Hacker News is actually goes to the Hacker News REST API and fetches the data, and then goes and data binds it and puts everything into the UI. Now, the next thing the system does is it correctly identifies the fact that, like, actually, even though all this data is part of the state of the application, there's no way for this data to be modified. And because no way for the data to be modified, there is actually no need to serialize it, right? There is nothing that the client can do that would cause a mutation to the data, which would then cause any of the components to re-render. So even though this is a pretty complicated site, the system correctly identified that actually no data needs to be sent to the client, and we just essentially end up with a quick static application. But now let's go to a particular comment. So let's go to a view of the comment. And this time we did serialize the state of the system. There's some data here. And if I scroll down, what you're actually going to see is it's going to say open true. What it's actually telling us is that we have a lot of these comments that are expanded and collapsible. And so let me just collapse one of them. If I collapse this, this is basically what allows the system to open and close the comment. Now, the thing that happens here is that whether or not the particular component was opened or closed was actually stored in the state of the system, as you can see over here. And of course, clicking on it consumes it. Now, what's interesting though is, if I do it again, is that the only thing that we have serialized here is whether or not the components are opened or closed, but you won't find in here is the actual text that came from the REST API. And again, it's because the system was able to identify the fact that even though this data is data bound and there are subscriptions on it, it's not possible to mutate it. And because it's not possible to mutate it, there is no need to send it to the client, because client cannot, any of the interactions that the client can do cannot result in modification of the data, because there's no modification of the data. There is no way to cause an update, etc. And so this data is unnecessary. So Qwik is trying really hard not only to be lazy in terms of the code that downloads to the client, but also in terms of the data that downloads to the client as well. And so the way to think about it is the application executes on a server, gets it to a correct kind of to some useful state, and at some point on the server we serialize the application and move it to the client and continue where the client left off. So let's look at basically how it kind of compares to other systems. So here is kind of how existing systems work. So let me show you the typical systems that use hydration. So you navigate, you get server-side pre-rendered application, and so everything is grayed out, meaning that it's not interactive. And because everything is grayed out, the browser needs to download the application code, right? This is the actual application that you need to kind of run. And then once you download the application, the browser can execute the application. And as the application is being executed, it can attach to listeners. And this is what we mean by it becomes blue, which is that it's hydrated. Now you can interact with these particular components, right? But my point is that the step 2 and 3 are expensive, and we would like to skip these steps. Now, at this point, people say like, oh, well, my existing frameworks support lazy loading, so I should be able to do lazy loading. And so when you do the SSR, you pre-render the same exact page, you download the application, you go and execute it, and now you come across a lazy loaded boundary. Well, it turns out because the component is visible on the other side of the lazy load boundary, you still have to download it. So the browser has to go back, download even more JavaScript, and execute all that JavaScript as well. So it turns out that lazy loaded boundaries in existing frameworks are only useful for components that are not currently visible on a page. If a component is already visible on a page, lazy loaded boundary actually is kind of detrimental, because now you have to make two round trips to the server instead of one. So now let's talk about islands. So islands was popularized by a framework called Astro. It says, you know what? How about we take the big application and break it out into smaller chunks? And then we delayed the hydration until the event happens. So for example, if I go and interact with this page, we just hydrate this piece of code. And if I interact with maybe the menu system on the left, only the menu system on the left will hydrate. And this is a great improvement because instead of having one expensive thing that has to happen all at once, you have smaller things that have to happen later. but it's still hydration, which means it's still the first interaction might still be slow. The other problem that happens with this approach is that there's no way, these are independent applications or independent islands. And because they're independent islands, there's no easy way to communicate between these islands. And so you have to solve the inter-island communication problem. Because, well, part of what existing frameworks solve is that when you have all your components in the single component model, an application, frameworks basically provide a way of communicating and sending data between components. And now that you've broken up your application into islands, you need to have some other mechanism for sending data across these islands. So let's look at Qwik. So the way Qwik is different is that Qwik is in also server-side mode where everything is pre-rendered, but it's all also inactive. But when you interact with a particular component, Qwik knows how to wake up just that component and nothing else on the page. So if you look at this specifically, notice what didn't happen. We didn't wake up the parent component and we didn't wake up the children components. We were able to surgically go in and say, actually, just this component needs to be woken up and nothing else. And the nice thing about Qwik is it also understands relationships. So if I go and interact with a particular component like here, it knows to also wake up another component, right? This is the inter-island communication problem that is fully understood by Qwik because the whole thing is just a single application. And so on and so forth. So we can have relationships. So the way Qwik works is that as you interact with individual pieces, we download just the necessary code for that piece of code and nothing else. Now I see there's a question about for low 3G connections, how do we handle this? Well, if we go to an actual website, so this is our actual homepage. Let's go to this page over here, for example. And in this page, if we make it small, the menu comes over here. And so this behavior over here, we want to make sure that that's quick when the first time you interact with it. And so what happens is when we navigate, Qwik also generates a prefetching scripts. So you can see these links on the bottom here. This is telling the system that even though I haven't clicked on anything yet, you should go and start prefetching all of these code because the user might come along and click this. Now, if you go back over here and you say, hey, well, isn't that the same thing as just doing this work when you start prefetching? And the answer is no. And it's no for a couple of reasons. First of all, the only thing we're doing is we are prefetching the code. We're not actually executing it, right? So right there, this box and this box disappear. So we're only left with this green box over here. But instead of downloading all of the code all at once, we actually know that the only behavior we have to download is the thing that is not static, right? So we take the existing application, and from this huge chunk, we are be able to identify only a small boxes that need to be downloaded, prefetched here. So the prefetching amount of code is much smaller than the code would be over here, and no execution and no reconciliation needs to happen. So the prefetching box that exists here right after the resumability happens is much smaller. And oh, by the way, the interactivity can happen before prefetching. The way it can work is that if you have 5 things that you're prefetching, and let's say the browser gets to first 2, but you prefer creating an interaction that actually needs the 5th item in the list, the browser will naturally reorder the prefetching links and start downloading the thing that's actually needed. So prefetching basically is a mechanism to make sure that we can download all the code and all the behavior eagerly on a browser without having to have the user wait on the first interaction. And of course, because Qwik cares about the whole problem end to end, Qwik generates all of this code for you. So it's not like you have to worry about generating the prefetching code or generating these URLs that exist in here. So let's go to this particular thing. So in here, there should be there's the on click. So there's a chunk over here and the piece of thing to download, etc. So Qwik takes care of all of those issues for you. So the only thing you have to kind of focus on is building the application in a traditional component sense. And you don't even have to think about lazy loading because all of that just comes in for free. So it's a good question about lazy loading. And it's also a very common question that people ask about it. Now, I can show you an interesting thing here. Let's disable JavaScript. If we disable JavaScript, let's refresh the page. What we're going to notice is that most of the page was actually server-side rendered, and it looks pretty much the same. The only difference we would have is that if we go to the mobile, this menu doesn't work, right? Because this is a menu that's driven by JavaScript, and of course the menu over here also doesn't work because that menu is also driven by JavaScript. So the behaviors that we broke is obviously the interactivity because we disabled the JavaScript, but for the most part, the page looks perfectly fine. And what's even interesting about it is we can navigate around. You could go to different pages. We can even go to the examples. Obviously, the example isn't loading and the app isn't loading because that requires JavaScript. But for the most part, the huge amounts of chunks of the app are actually working just fine. And the reason for that is because, well, all of this executed on the server was cached at the CDN, and there because there's all cached on the CDN, it's just available to the browser as HTML. But if you think about it, this is also an ideal behavior for search engine optimization because search engines need to go and navigate to your page and see the content. And not all search engines are able to actually execute JavaScript. And so it's a nice feature that all of your code actually becomes search engine optimizable out of the box. Now, if you go to example, we actually have a whole bunch of examples here. And again, it's not downloading because it's JavaScript is disabled, but or actually, let's go to tutorial. This is a REPL, right? Which is a common way people show off the capabilities in the browser. And notice that in most systems, this would be a full-on application with lots of complicated interactivity. Obviously, it's broken because JavaScript is disabled. But notice that the code, the text, is properly generated. And so search engines will see all of this content, even if they won't necessarily see the application running, right? So we have quite a lot of application actually still working, even with JavaScript disabled. So let me re-enable JavaScript again. Enable JavaScript, here we go. Let's refresh the page. And now we should have the code loading over here and kind of the behavior on this side as well. Oops. And we have the menus working. Sorry, menus. If I go here, the menu should be working and so on and so forth, right? So that's kind of the overview. Let's see, what else can we show? Talked about this. So I want to show you, before we jump into questions, I want to talk about one more thing and then we talk about questions. So this demo that I showed you here, which had the Hello World, interactivity, clock, etc., they seemed like separate applications, but actually this whole thing is actually a single application. And let's go back to the network tab again. And even though it's a single application, the amount of JavaScript that downloads is very lazy. And so let me show you all of these demos running on a single page, right? So this is a single page. Let me refresh this again. That contains the Hello World. It contains the counter, the click, the to-do app, and even the clock. And notice that this single page that contains everything has the natural behavior. No JavaScript. Scroll the clock into position. JavaScript wakes up the clock. Clicking on a counter downloads the behavior of the counter. Clicking on the debounce counter downloads the behavior. Interacting with our to-dos downloads even more behavior. And again, clicking and interacting with the code all just keeps downloading more and more behavior. And so the way you look at it is that, notice the waterfall here that's happening, right? Oops, what did I do? I broke it. Okay, this waterfall here is driven by user interactions, right? So as the user is interacting with the application, more and more JavaScript is being delivered to the client on just needed basis. And of course, we have prefetching, but we can do even better. It's not a feature that is yet implemented in the system, but it will be relatively straightforward to implement, which is that you could just keep track of statistically what is the user's most likely going to interact with on a page. And as the user interacts on the page, we can change the order of prefetching by the probability that this interaction actually happens. So we can do tricks like that. Now, I want to show you one more demo, and then I will open it up to questions. So here is a to-do app, and I kind of showed you that we have the state of the applications inside of this JSON. And let's say we create a new item inside of here. And so you could see that the state of the system kind of got consumed. And you can also see that the container is no longer paused. It says resumed. And so if I click, hey, let's refresh this again, see it says paused, and we have the JSON. And if I, again, type in new item, it becomes resumed, and the JSON has been consumed. Oops, typo. One of the things we can do is we can recover the state of the system. And the way we can do that is by going to elements. Let's see, selecting the HTML, go in here and saying quick.pause. When I pause this, I have again gotten back my JSON representing the state of the system. Now, one of the things I can do is I can copy the whole thing and copy outer HTML. So I grab the HTML of the thing, and let's go to a new page. And on this page, we can go and we can see that there's HTML. And so let's delete this. I'm just going to delete the HTML here. And so we have a blank page, and I'm going to edit it again, and I'm going to paste the HTML from the other side. Now, the fact that the HTML came over here and rebuilt the application, that in itself is not surprising, but will the application be interactive? And the answer is yes. Not only is it interactive, it actually noticed that it actually understands that I have entered a new item. And so I can go and check the item, hide it, or show it again, and so on. So the application literally resumed where I left off, right? So we had an application running on a server. We paused it. We delivered it to this browser tab. I interacted with the application a little bit. I saved it, moved it over to a second browser tab, and I continued where I left off from the previous tab. And so this is really what we mean by resumability. And if you step back and if you think about it from the way of like the virtual machines, I know when virtual machines first came out, I was just absolutely amazed that I can, on my computer, I can boot up a virtual machine. I can, the boot up process gets to a certain point, and at some point I can open up, let's say, Chrome or navigate to a page or Word document, and I can edit the Word document. And at some point I can just save the virtual machine into a disk. And I take that file and I can, send it to my friend, and my friend can open the virtual machine, and he doesn't go through the boot up process. They literally are exactly where I left off, with my Windows open, positioned on the screen and everything. And they see that the Word document I was working on, and they can just continue working where I left off. And so what they just saved themselves is the whole boot up process of the computer. And this boot up process is essentially equivalent to hydration. And instead, with resumability, we have this idea of like, well, we can just serialize all of the state into the client in such a way, into the HTML in such a way that we can transfer it over between different tabs, between the server and the client, or between different tabs, and continue where we left off, saving ourselves basically the cost of Bootstrap. Anyways, with that, I'm going to pause this and see if people have some questions. And let's see.
Yes, we have one from Rodrigo. So for low 3G connections, is there a way to preload this bundle? So I think this was earlier on.
Yeah, so I already kind of mentioned this, that yes, absolutely. So one of the things Qwik does is it produces these prefetching code, right? So in the real application, if you actually go to the network tab, let's get rid of this, and all code. If I refresh this and I do Q dash, is it Q? Disable caching. Sorry, let me re-enable the caching here. You see that all of the chunks are prefetched, right? In this particular case, they all came out of memory because they already existed, but they're prefetched. So if I go and interact with the page and I click on the button, when the browser actually goes and fetches it the second time, they are all from prefetch cache, and so there's no cost to it.
Great.
Rodrigo is also asking, can the application state be seen in a database? Yes, so the application state, in essence, let's go to a simple example. The application state is essentially this Qwik JSON right here, right? This is our application state. You can think of it that way. And in here, we store all the state of the information. So for example, we store the count being 10. Now, this 10 actually has to be in sync with this 10, but we can cheat actually before we do an interaction, right? Before the framework woke up and consumed this particular piece of code. Let's see if we can edit this. Oh, I cannot edit this. Oh, wait. Edit as HTML. Here we go. So let's go and let's cheat here and let's make this, for example, 50. So if I change this to 50, obviously there's a discrepancy now between what the state of the system is inside of the state here and what it is in the UI. But because no JavaScript has yet run and this code hasn't been consumed yet, when I click here, I will get 51, right? Because the state of the system, which was essentially the database, got consumed here. It was 50 because we modified it. And so when this thing incremented, it became 51. And then we downloaded the JSX to update the UI, and we ended up with 51. So the source of the truth is actually stored inside of the Qwik JSON right over here. And it's essentially the application state right there.
Great. Thank you, Rodrigo, for those questions. Can wait just a little bit longer if anyone else has any other questions. Go ahead and drop them into the YouTube chat. If you're watching this later and you do want to ask some questions to Mieszko, please make sure to follow him on Twitter and ask those questions there. Looks like we are set on questions. Mieszko, thank you so much for such a great presentation. I know a lot of people got a lot out of it, and a lot of people are looking forward to watching this later on repeats. Thank you so much for your time, and we will see each other later.
Okay.
Have a great day, everyone.
Thank you so much. Just wanted to, before I leave, just wanted to point out, qwik.builder.io is our webpage. Come and check us out on Discord. We have a community going over there. We have lots of examples and tutorials on how to use this thing. You can try things inside of here as well. Hopefully I was able to convince you that Qwik is a very different approach to how applications are actually built. And I think this is going to have a huge impact on startup performance of our existing applications.
And we will drop those links for everyone in the description of the video, so you can follow along there. Thanks again, Mieszko. Always a pleasure.
Thank you.
See ya.